And I'm back once again. This is now chapter 6. I'm in my pajamas again at night. And this time we're talking about the skin, the integumentary system. We'll go on two parts here. We're starting part 1 here. This is a generic diagram, nice use for labeling here, where we have the epidermis, the dermis, and then the portion that's not actually part of the skin, the subcutaneous layer with fat and other types of connective tissue, loose connective tissue. We'll talk in detail about the epidermis and the dermis mostly, and all these various structures that you see, including the oil glands and the hair follicle, and so on. All right, so let's get to it. What's the purpose? What's the most important function? It's protection. What else does it do? Well, the 5 major ones are protecting as a barrier or acting as a barrier, regulating body temperature, removing waste products from the body. So this would be through sweat and through secretions in the oil and so on. Protection against UV radiation, and we'll talk about melanin and melanocytes and so on in a bit. And then also in the production of vitamin D, which also comes from exposure to the sun, vitamin D being important for calcium absorption, we'll see soon. So the layers we said: epidermis, dermis, and subcutaneous, which is beneath the dermis, sometimes called the hypodermis, hypo again below, and it's not actually part of the skin. Specifically, we'll start with the subcutaneous layer and just get through that. It's made up of loose connective tissue, which includes adipose tissue, and its purpose is to insulate, keeps you warm, and so on. It also carries the major blood vessels, which then branch off into smaller branches and capillaries and so on to carry blood to the dermis. You will also notice, to point out now, that these blood vessels don't go up into the epidermis. They only go up to the dermis. But the major ones are in the subcutaneous layer. The epidermis is the outermost layer. It is stratified squamous epithelium, which you know, and it's largely dead cells. As they die, they become keratinized. And these remaining cells of the epidermis will actually, those that aren't dead, do mitosis really fast all the time. And this is because these cells that die are constantly needing to be replaced over and over and over. So, for example, my arm here, the cells on the surface are dead. So if I go like this, what I've just done is created a bunch of skin dust on my counter. You can't see it, but there's a bunch of skin cells that just fell off of my arm onto the table. That's great to think about. And more will be replacing it constantly. It's thickest on my palms and on the soles of my feet. And the more I do this, the thicker they get, sometimes in the form of calluses, but often also just in general, the thickness gets wider or bigger. As these new cells are produced, the old ones go to the surface and they become keratinized. I told you, they flatten, they lose their cellular contents, and they start to make keratin for protection and rigidity, toughness. And we already told you that the epidermis lacks blood vessels. So keratin is a really tough protein. You might know of it from nails and also hair, and even in calluses it provides that really dense, tough skin that you might be familiar with. And the keratinocytes are the cells that produce the keratin, that are going to die and then form that tough barrier. And just to give you an idea, every 2 to 4 weeks you lose your epidermis, your skin, and refresh the new ones coming in. So all the time you're losing cells, and making new ones. Now there's 5 layers of the epidermis that we subclassify from the bottom up, essentially, from superficial to most deep, as shown. The top, number 1, is stratum corneum. And number 2 is stratum lucidum. Number 3, stratum granulosum. And here you see they're just starting to die and be filled and keratinized. Stratum spinosum, down here where they're normal, completely normal cells. And stratum basale, these are the ones that are attached to the basement membrane. And this is stratified squamous epithelium, of course. And yes, you do need to know these in order for the epidermis, of course. The dermis, the one in the middle, it's on average 1 to 2 millimeters thick. And here is the cause of our fingerprints. The dermis is what causes these slight protrusions and depressions in your finger that cause your fingerprints. It's from the dermis, not actually the epidermis. The dermis is what binds the epidermis to the underlying tissues, including the subcutaneous layer, of course. And it's made of dense connective tissue, as well as some muscle cells that we'll talk about here in just a bit, such as the erector pili muscle here. And then there's also nerve endings. This, of course, is why you can feel, if you pluck out a hair out of your arm, you can feel it because there's a nerve ending attached to that. And then there's other specialized sensory receptors for temperature and pressure and so on, and we'll talk about those. And then we already mentioned also very small blood vessels like capillaries carrying blood up to the dermis. hair follicles, which you can see and know, and then also glands that secrete stuff like sweat. Specifically with the hair follicles, we're focusing in here. So hair follicles made up of the actual epidermal cells that are dead, and just to point out, the follicle itself that you can see that the hair is growing out of is epidermis that plunges down into the dermis. You can see this pinkish layer all the way around the hair itself from the epidermis, and these are dead cells from the epidermis in this tube-like depression that the hair grows out of. It extends all the way into the dermis, as you can see, and then there's a hair root at the bottom. Here you see the hair root. That's the part that is going to be attached to the hair follicle itself and to the hair papilla. And then you have the hair shaft, of course. That's the structural part that you think of when you think of a hair. And then the papilla at the bottom, which is the attachment point of the hair. And to give you some idea, people often talk about shaving, for example. If I take a razor and I just chop off this surface layer of hair, well, the rest of it is still beneath the skin, and it's just going to grow straight out. One thing that people talk about is, does the hair grow back faster if I shave it? The answer is it doesn't grow back faster, but it grows back thicker. And an easy metaphor to think about is on a mountain, if there's a tree growing and that tree is exposed to a lot of wind, that tree is going to grow shorter and fatter. It won't grow as tall, but it'll grow wider to give it strength and structure so it won't blow over in the wind. So as you shave hair and you cause vibrations on this hair, your body's going to respond by producing thicker, more coarse hair as opposed to longer or faster growing hair. So it doesn't actually grow back faster, it just might grow back thicker or darker when you shave it. This is also why some people, for example, especially the ladies, will pluck their eyebrows out because that hair takes the entire shaft all the way down through the hair root and pulls it out. So the hair has to grow all the way back to break the surface of that follicle again before you see it. So it takes a lot longer than just shaving it. We also have melanin produced in the hair follicle, giving the hair its actual color. The same melanin that provides skin color as well as eye color. And then the erector pili muscle that I mentioned is shown here. You see how the muscle is attached, where when this muscle shortens, the hair itself is going to stand up, and this is tied to goosebumps, of course, and temperature regulation that we'll talk about later. Nail bed, your nails. 3 components, 3 parts. So it's meant to protect, of course, the tips of your fingers. There's the nail plate, that's what you normally think of as the nail. There's the nail bed itself, the part that it rests on, which hopefully you never have to see, but sometimes you lose a nail. And then there's the lunula at the top, that's the whitish portion that you can see here, and take a look, we all have that lunula. It's a labeled or named region. Those are your nails. And the nails, of course, are made of keratin, right? Types of glands. So we have sebaceous glands, and these sebaceous glands are associated with hair follicles, and they're a type of holocrine gland, so they secrete oil. Oil that's called sebum. Sebum is not a homeless sea wayfarer or someone who's homeless living on the sea. It's the name of the oil that's produced by your body. And over the course of the day, you get more and more oily, of course, and then you take a shower and you rinse off that oil, and then you start to produce it again. You actually don't have these holocrine glands and these sebaceous glands in your palms or the soles of your feet, so you don't produce oil. That would just be awkward if you had an oily handshake every time you shook somebody's hands. All right, so that produces the oil associated with your hair, and why your hair, as the day goes on, gets more and more oily. All right, different types of sweat glands. Sudoriferous glands, that just sounds smelly, are all over the skin. These sweat glands are, and they originate in the dermis, sometimes all the way down in the hypodermis, but mostly in the dermis, where these sweat glands are. And there's different types. There's eccrine glands, apocrine glands, and then specifically ceruminous and mammary glands. Eccrine glands are your generic sweat glands. So when I go for a run and my arm here sweats, it's sweating because of eccrine glands. Okay. In my armpit, when I sweat, that sweat is a more fatty type of sweat, and this is the sweat that actually bacteria like to eat. This is the sweat from apocrine glands. So common in the armpits, the bridge of the nose, the genital area, and so on. So the bacteria like to eat this sweat, and as a result, the bacteria produce toxic gas. Toxic because sometimes other people will smell it, and it's quite off-putting, of course. This is your BO, right? When the bacteria eat your fatty sweat from your apocrine glands. Now, ceruminous and mammary glands, these are specific types of apocrine sweat glands. Ceruminous makes cerumen, which happens to be earwax. That earwax is produced as a protective mechanism so that other things like bacteria or bugs or what have you can't climb in, which of course would be not ideal. And then you have mammary glands, which produce your milk. We told you in class today that mammary glands were modified sweat glands. I know, weird to think about. In the dermis, we have the ability to feel and send that message to the brain, of course. So all the different types of ways we can interact with our environment through our dermis include deep pressure. Okay, I push really hard. I can tell it's different from light pressure. The deep pressure is from a type of receptor called Pacinian corpuscles. It's a weird sounding word, but it's worth pronouncing on your end. Then there's light pressure. It feels more like a tickle. That's Meissner's corpuscles. And then we have warm and cold temperature, which we just call free nerve endings. And you'll notice they're the same sensory structures. Many of us have probably experienced something so cold that it feels hot and it feels like it's burning. In fact, I had a friend growing up who was a pitcher, and after a game one day I was over at his house and we were watching TV. He was icing his shoulder. He put the ice directly on his shoulder. 30 minutes later he looked and his shoulder was all red. He actually had a second-degree burn from the ice because the ice was so hot, if you like. These free nerve endings are the same for warm and cold temperatures. And then pain is also free nerve endings, but slightly different. But this is why hot and cold can cause pain like other types of things. And we'll take a pause here.